So we're gonna talk about vocab today. This is really meant to be like, hey, there's some terms that I didn't even know that I didn't even know what to call this. So a lot of this is stuff that I've learned, but to give you a better understanding of when we say something, what that's referring to. And this will be shared so that everybody can um, kind of work their way into using this. I'm not going to quiz you on this. This is not a test. So it's just meant to work us through like what the things are that we talk about. So to start off, we have the ribbon, which is the main thing. Like AutoCAD has a ribbon. It's just where all the tools are. That a ribbon consists of the different tabs up here, the architecture, structure, steel all the way across, and then all these buttons that come with it. The other thing too is there's the bottom level of the ribbon that says the build circulation model that can help you understand where you're actually trying to get um, to know what you're trying to look for. So that's the ribbon. The quick access toolbar is above the ribbon. It is the quick little buttons where you want to have your save, your sync button. That's your undo, your quick print, your pen dimensions, quick just to measure something or to do dimensions. But then you can also just like customize this toolbar for whatever you use. So that's just above the ribbon.
Are we asking questions today like what's the difference between a regular dimension and a pen dimension, or are you just going through vocabulary right
I'm just kind of going through vocab. If you want to
now? Okay.
save your questions for the end, that
Yep.
would be great. But really, um, it's really just trying to let's just kind of go through. There's like 40 of these, so I'm just
All right.
trying to breeze through them. The project browser is where we go and view all of our views, our sheets, our legends, our it's essentially the tab on your DWG for your sheet, and sometimes you'd have like four sheets tabbed out. Well, now we can have everything. We can see everything in the project browser without having to open a different file. So for all you CAD users, you're not saving files out. You're just it's
You
being
have to get
saved
it.
to
You
your
have to get
project
it.
browser.
Just need
Okay,
a little
so
something to
under
work.
your project browser, you have your properties. This is where all your parameters and the settings for the object or the sheet or the view that you have are. So whether it's anything has properties to it. So be sure to look here if you're looking for to be able to change something or to understand what the quality or what something is. Your options bar. This is the little green bar that pops up under the ribbon when you select like a wall or a floor. But typically it's giving you a highlighted understanding of where you're going to place the wall, the height it's going to be, where it's located. Is it going to be chained? Like if you click, 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 will they all be connected or are you going to like end the command with each click kind of thing? And then there's offset and then some joins. So this is a sort of a dynamic toolbar that allows you to do something when you're in the middle of a command so that it'll disappear when you exit the wall command. The view controls bar, this is at the bottom of your view window. This is where our scale, this is our detail level. So right now that's a medium detail level. How we view the model, if it's viewed in like a hidden line, which is typically how we see things in black and white, or if it's shaded or consistent colors. There's some shadows, sun path. Do we want to see the crop region? Do we want to lock the 3D view? There's a bunch of tools down here that we can cover later on, but that's your view controls bar, and it's on every view. You can control your view that way. Then below the view control bar is your status bar, and you can kind of see there's the little remnant of the view control bar. The status bar helps you know what you're selecting. So in AutoCAD, we have the script bar, and that's like lets us know like where we're going to type something. Revit doesn't have that. It's the only way we really know what we're selecting or highlighting is by looking at the status bar, and it'll kind of tell us you're hovering over the wall, or now you're hovering over the door, or now you're in the room. And that's just letting you know what it is that you're kind of hovering over before you select it. Okay, a family is the basic building block of Revit. It is anywhere from the sink that we wash our hands in to a towel bar to a wall or the view title on the sheet or the title block. All of those are families. So it can be very generalized sense, or it can be like, hey, interiors needs a piece of furniture that they don't have yet. They need me to make a family. Or Keaton is tagging condo plans and he wants to change how a tag looks. That's an example of like needing a new family kind of thing. So this a general sense, families are very broad based, and then we can get into more finite, granular details of what the actual family is referring to. And so within families, we have these two little understandings of parameters. There's a type parameter and there's an instance parameter. And the type parameter is something that affects the instance of that family type in the project. So if you have a 36-inch door, every time you put that 36-inch door in the place, it is a typed parameter for 36 inches. So if you go and say, well, Jim Bob told me to make the 36-inch door the 34 inches in this location. Well, if you go and change that type parameter for the 36-inch door to 34 inches, then every single 36-inch door is now 34 inches, which is not what we'd want to do. So that's the understanding that we would want to make sure that we understand what we're changing so that we can understand the repercussions that that has as we design things. And an instance parameter is great. That's like a door tag. Like, hey, my door tag in this location is this only number. And sometimes we have the same door tag in different locations, but we do door tags kind of separately from that. So it's instance parameters only control the singular object. Like it's the one thing, and then the properties that I showed you, it's the first image. That and the you don't have to jump into a type thing. But if you the instance parameter is singular, type parameter is every single type in the building. So this is trying to reinforce like what is an instance and what is a type. And so within families, we have a category, and that category allows us to pick certain areas that we want to put the thing in. Like obviously, if we have a window, we want to model it as a window. We wouldn't want to model it as a site element because then we couldn't schedule all the windows together. So it's really important that we make sure that the elements that we want to categorize are categorized properly in order for us to have the proper schedules as we work through the project. Constraints, these are things that, to Chad's comment, we can constrain dimensions. And so if I say that my building is no bigger than 208 feet long, and I set that, and then the dimension string is locked, which is just making a dimension and then locking it, it is constrained. It cannot grow bigger unless you unlock it and then do that. So that's a great way that as we go through product library stuff or as we work things, like those exterior walls are immovable unless it is a known thing that we're doing. So it's a great way to kind of lock things down to make sure that what we've designed is not changing. Okay, so a work plane is trying to break down the way that Revit thinks of a plane. So we can think of the plane being the ground floor, but we can also change the work plane to being the vertical plane, or it can be a section plane. We can tilt the work plane, but that's a way that when you model something or place something, you can place it on the work plane, and then you can obviously have that vertically or horizontally. So it's kind of the thing in space that we attach things to, and then we can modify where that work plane is. So a great example of a work plane in Revit is a level. So levels are typically where we put our benchmarks for our floors. You can make, these are infinite, we can make as many as we want, but really we want to make sure that we are just identifying the level floor plan that we're at. And then we really don't want to go into like, hey, we did this on River Lights and we had to remove it, but where the ceiling of the first floor is, and then the second floor is, and then these two lines wind up being really close together, and it's not necessary for us to have a ceiling datum. We can just put another plane in that's not a level. So it's just those are levels or horizontal planes that typically represent floors. And grids, we don't really use grids because we don't have like necessarily huge column layouts with concrete structures or steel structures, but it's the same thing. They're just vertical planes that help us divide the building into pieces. And so going back to the project browser, we have our views, and our views are representations of our project. So it's like you can create a viewport and of your model space and take your snapshot, and then that's saved in your project browser. And so when we draw a section, we're trying to draw a section line. We can jog the section if we wanted to. Um, and then that allows us to like literally cut the model and then see what is modeled to where we can add information to it. But it allows us to kind of quickly create these drawings or the layout of space so that we can begin to understand what more needs to be done. So as these are things that with views, especially for the new users, don't be afraid to create a new view. You can create thousands of views and then you can easily quickly delete all of them. So it's just be comfortable with being able to make your own views and being able to say like it's all about viewing and seeing more in Revit. The fact that we don't have to draw or draft a section to be able to understand what I just modeled is sort of the keystone of what Revit's getting at, is that we don't have to spend the time drafting something that we already know and already have drawn in elevation. And so with visibility graphics, this is if we ever tell you to hit VV or VG on your computer, this is the window that's going to pop up. This is the layer manager of Revit. So you can kind of see there's all these categories that have check marks. And so those are check marks that are visible. If I uncheck the check mark, then it is no longer visible. So it's easy as that to just be like, I don't want that, freeze that layer. And so with the visibility graphics, we can then say whatever my cut pattern is or my cut lines, I can globally change the parameter, the value of walls from say like, hey, I'm showing a stud wall to be white as a cut pattern, but actually I'm in DD. I just want to show my cut pattern to be like a solid gray through my whole wall because I'm not worried about finish right now or showing line layers and all that. So you can come into here and override your cut pattern and then press OK, and then that changes the whole setting for that view. So it's a lot of learning how to use this and learning how to use the project browser and properties are like really cool of like how we can manipulate the data that we're seeing to see it differently, but we're not adding or deleting anything. We're just kind of changing settings. And so with working together, we have this thing called work sharing. And work sharing is really just the ability for us to have a one file that we all go to open, and then we each check out a local copy. So everyone in this call could be in a file working together as long as we're in an area we're not stepping on each other's toes. But then we can all sync and save and then like be working together because of work sharing. And so the way the central model works is that BIM 360 is our server essentially. It's where we go and save all of our information. And so when we check it out, I would go and open a file that's opening a local copy on my computer. Matt would go and open the same file, but he's opening his on his computer, which is his login. So if I like am working on the first floor plan and Matt's working on the roof, we can be saving and syncing, and he can go down the first floor plan and be like, "Oh, Kurt, you've done some great work down here. Um, let me know if I need to help you with anything." But then as he syncs and saves his roof stuff, I can begin to see his thing. So it's just an interconnection of back and forth. It is prudent that as you work in Revit, that you save your and sync your work. If you are not doing that, people are going to come in and say like, hey, you've like touched the whole model and I can't touch anything and I need to be able to do work. And there are ways that we can kick you out of a model, which are very detrimental to like the way that we work collaboratively. So it's just, I'm going to hash that over again. You have to sync and save your model frequently. You're going to get a warning that pops up that says, do you want to sync and save? Um, don't ignore that for half a day or a whole day. That's just bad etiquette in terms of model behavior. And so talking about syncing, when you sync your local file, you're going to get this little screen that's just saying it's saving this local file, it's reloading the latest, it's saving everything to the central, and then saving my local. And that's a process that it will go through as you sync and save the model to make sure that your work is added to the central model and everybody else can see it. Okay, work sets are great. They are the it's kind of in the same vein as your layer manager where you can turn stuff on and off, but it's not meant to be a way to visibly control things. It's really meant to be like, hey, I have massive pieces that I want to like either keep on or keep off all the time. So a great one is the site. I don't need to see the site all the time. I only need to see the site and my site plan. So if I have a bunch of parking and cars and trees and all that in my model, and I keep it on a work set that's on off, my model's going to move a whole lot faster. But if I have everything on and everything like re-rendering and re-rasterizing as I'm moving around, my model's going to move really slow. So if you've ever gotten in a like fully developed SketchUp model and realized how slow it is to orbit, it's because it's trying to re-render every bit of that geometry that it can see. And so what we do in Revit is we put stuff on work sets to like all of our units are divided into level one, level two, level three. I can turn my arc off, so I can turn all of my architecture off to be able to see just structural. And then vice versa, I can turn structural off just to see architectural. So we do this to be able to alleviate the model speed problems that come with having everything on at one time. Okay, and so we do one of those things with linking. So this is very similar to an XREF. It is a file that I have inserted into uh, my project. And so you have different links properties. You can have a Revit link, an IFC link, a CAD link. You can do DWFs. You can do point clouds, topography, PDFs, and images. So images are cool because we can actually like put images on here. Like if we wanted to put renderings, we can put them into our project that we've made, and then they can become part of the construction drawings. But for us, we deal a lot with our Revit links and how those are all saved to the uh, Autodesk Construction Cloud, and then we just can manage them. Typically, you'll get an opening when you open the file that, do I need to look at the links? You can, you don't have to. Sometimes you're just like, I'm getting here to do the work, but this allows us to kind of see, oh, something, maybe my unit got unloaded and that's why I'm not seeing it. So maybe check your manage links and all you have to do is then press the reload button. Sometimes they lose their path. And so just a quick way to look at why am I not seeing the thing that's supposed to be here? Okay, and the difference between a link and a group is a link is a Revit file that I've brought in and I'm keeping it as its own entity. A group is something that I can bring in or save within the model that allows me to keep that collection together. So that way, when I copy it, it's the same thing, but it's still editable. So right here, you're seeing an example of a toilet being copied over. We use this a lot with windows and trim because the windows and trim are repetitive elements, but they change at the same time together. So like we have trim, we have the window. Sometimes we go from a 6/6 window to a 3/1, and then the trim went from a 1/6 to a 1/4. Well, that would take, let's just say you had 300 windows on a project. Think of the amount of time that it would take you to change each and every one of those windows. The reason why we go with groups is so that you can change that thing one time everything's changed in that one instance, and then it makes the reflection on all the windows at the same time. So as you build things, you want to make sure that you try to think of, hey, this is repetitive element that I need to be able to edit in the future. Make it a group. Um, these are things that can save to the project browser and we can come back and edit them. So it's just, these are great tools to remember. Okay, schedules. Schedules are probably everyone's bane of existence. I hated them and I only like them because I'm good at them now. Um, the a schedule is the way that we like quantify the things that are in the project. No longer are you doing something in Revit that you would do in CAD and then get an RFI to be like, I don't know where this building or this window is. Like it's not tagged properly, it's not coordinated. Like if you have it, if it's not coordinated, it's not coordinated in the schedule. And so project managers, this is a great tool that should be worked on before the end of the project. Because if you can conquer this, you can better understand the whole project and know what's going to happen. Because these are typically afterthoughts that are done with the last 3 days, and then you're scrambling trying to figure out what's going on. So because it is tedious and it can be cumbersome and nobody likes to do it, um, it's better to just go ahead and get on the bus than to not. So um, okay, sheets. Sheets are paper space in CAD. They essentially have the ability to drop a view in to create a viewport, and then obviously it's got your title block on it. So the title block is the X border. So we can have the title block be an 8.5 by 11. It can be a 30 by 42. It can be whatever we want it to be. But then when we print, it's going to print to the extent of the title block. So if we have views that are off the title block, sometimes it'll cut that view off. So we want to make sure that everything's kind of in that view, but we can just drag and drop stuff into this paper space and be like, format it, and then realize it doesn't work and delete that out of the sheet. And we still have the view, but it's not in the sheet anymore. Okay, and so tags kind of relate back to schedules, is that tag, the E7, the E4, the D1, those are like values that are parameters that we have designated as that type. So if I change that D1 to say an F1, all those D1s are now F1s. So the ability for us to say like, hey, let me just tag everything and then change the value of that tag, that type parameter tag, to then be like, that's the thing that works. That's the way we're going to name it. That's an easy way to change that. Or you can go back to your schedule and say, hey, this in the schedule, I'm going to change the type mark from E7 to E8 because I actually have two E7s, like that are two different walls. So the tags are really great at helping us understand like, why is that different? Why is it the same? Like they shouldn't be the same kind of thing. So there's just tags are great because they're actual live data. It's not just like graphics on paper telling us something that I have no clue why that's that tag. Okay, in place families. These are great for custom pieces like trim that is for a custom bank window door. It's just we wouldn't want to make a family for it because it's just we don't do it very often, but you just kind of need to have the look that you're going for. And so the best thing to do is just to bite the bullet, go model in place, pick your category, and start picking your geometries of how you want to do that. This is great for like if you have like a knee wall or something that's like just not working with the site that you can't figure out how to do it. Again, trim. Um, there's just a few things that you might want to model something in place, like model a floor in place that's like it's I don't know what this is, but you're just trying to create some variety. Um, that's an in-place family. So it's like there's that level of customness to Revit that maybe y'all are used to with SketchUp. This is that, but try to avoid this with just you shouldn't make the whole building a bunch of in-place families. That's just bad etiquette. Um, okay, hosted and hosted elements. A host is the thing that the hosted element is on. So if I have, two walls that are perpendicular to each other, and I have a window on one wall, but I want to put it on this other wall, I can then say pick new host, and then it'll just go to that other wall. I can't actually like move it, like do the move command to move it there. I have to like tell it it's changing its host. Um, if you delete the host, you've deleted everything that's hosted to that thing. So if you're like, I'm like raised earth deleting pieces of a building, and I delete the exterior wall that has all the windows in it, but I actually wanted those windows, then you've got to figure out a solution to like change that wall and keep those windows. So there's solutions to that, but just know that if it has a host and you delete the host, you've deleted the element that the thing's hosted on. So it's um, hosted elements. Um, that's a terrible picture. Uh, the family editor. This is where you would go to change a family. So with sinks, cabinets, doors, windows, most everything except a system family, which are walls, floors, ceilings, railings. Those are things the that we can edit. We have an option to edit the family, and typically this is something you would probably ask me or Elliot or someone who knows or has built the family to say like, hey, can you help me with this? Because this gets into a whole other world of Revit. But if you need to change something like the way a tag looks, the way a window is being represented, the way that the door swing functions, like that's when you go into the family to edit the family. Um, Again, this is something that is not easy, but if you wanted to jump into this, I'm more than happy to kind of walk us through how to do some of that. And then parameters, this should have probably been with the type and instance, but these are just values that we have. So like I have a leader line parameter, and like again, I didn't put the leader line parameter here. It just is part of and built into something in Revit. But that is a parameter and it has a yes, no value. So this orientation is a like selectable item. I can change the angle of my wall tag to rotate and whatever, and then I can make sure that I haven't attached into the leader line, or if it's free and I can like move it to wherever I want to. So those are just like a tiny snippet of parameters. We use them all over the place from right now in our site planning work, we're adding parameters to be able to calculate like bedroom and parking load. So that way when we schedule the all of our site planning blocks, we already know unit count, we already know parking load count because those are parameters that we can add in of values that we already know. So parameters are very valuable, and it's just a word that means it's a thing of data that can hold value. And so with parameters, we have shared parameters, and shared parameters are things that we want to be consistent from project to project. And that's important because like Casey had one this past week for Point Hope where we have our distribution log and then we have our revision log. And so with our distribution log, we want to show our schematic design, our design development, and our permit drawings. And then when we're done with permit drawings, we issue one IFC set and all those other dates are cleared out. And so to make those consistent across every project that we do now, we have shared parameters which have SD date, design development date, permit drawing date, and IFC date. And so as we develop these things, we can start to think about like, okay, I want this to be consistent across all projects. That's going to be a shared parameter. Like, and so that way, when we schedule things, that it's always looking at the exact same parameter. And so these are things that we develop, we can like talk about, but it's a lot of this is very, hey, let's talk about this before we just start making shared parameters. Sections, callouts, and elevations. Going back to our views, where are our views stored? In our project browser. So when I draw a section, a call out, an elevation, a plan view, a 3D view, all of these would be generated in my project browser. It will open the view as you create it, but when you like are going to find it, it's going to be in your project browser. And so I can easily right click on the tag or the call out, and then say go to view. And those are those things. It's just like it's dumbing down the struggles that we would have in CAD of like, okay, well, I have to make an elevation. So I have a plan and now I have to actually elevate it. Well, Revit's like, I got you, dog. Like it's already made. So when you are doing that, you're actually like cutting the element. Like there's a cut line and then there's a view line that we can move and reflect that you're looking at a 3D image. And so we're gonna go jump into like detail views and drafting views right now. So detail views, like you can see on this right side, this is really a wall section, but we're adding detail to it. So we can add this truss, we can add the insulation lines. Um, some of these footings are probably detail regions in here. And so that's a really nice looking section. You know, they've got some notes here. We've got some call outs. We've got some dimensions. You've got your level lines. That's a really looking good drawing, good looking drawing. That is pulling model information and we're adding detail information. The benefit of the detail views is that like as the model changes, you can see that reflected in the view. So if like Keaton and Joe were like, "Hey, dog, our like corridor is actually 4 feet now." They like cheapened it up and are like, "It's no longer the 6 foot wide corridor. It's like you're gonna be walking through, you know, a hospital corridor." So if I move the wall, all that annotation, the installation lines, the where the truss is, all that's gonna like stay where it is, and the wall's gonna move, but the insulation, the detail's not. So the reason why that's important is because sometimes like we don't need to add all that extra detail in certain drawings. Like in our overall draft building section here, there's not you don't see that installation lines, but that three A313 is showing me this. So I went from blocked out solid poche to nice detailed drawing, and it's the same thing I'm looking at. So detail view, drafting view. A drafting view is like that is CAD in its essence. This is what like Revit took what CAD does in like very 2D dimensions. It's just like I am drawing lines and I can put hatch patterns in it. There's nothing flexible. This is completely devoid of the model. So like these are great because we can share them from project to project and they're not project specific. They can be, but they are not like modeled elements. So I can easily copy out of Everly and put this into Point Hope and be like, it's the same brick ledger detail. Like they're not going to know the difference. Drafting views, detail views. Drafting views. All right, we're good.
Okay.
3D views. We have a default 3D view. Most of the time, it's going to come into you in an orthographic projection. So if you see it, it can anybody that's not an architect will come to your desk and be like, why does it look so weird? Because it's not in perspective. Because when we look at stuff in Revit, we like to see things in isometric orthographic projection. You've got your little steering cube up here. That also comes with the steering wheel where you can orbit and stuff like that. I'm not going to go into how we manage 3D views, but this is just a way to see something where you're like, I'm used to seeing it in 2D, like an elevation plan section. Let me see what it looks like in 3D so I can understand how everything's happening. Material browser, this is the um, like the Sherwin-Williams store of Revit. This is where we pick all the materials that we want. We have our sort of internal library that we're still developing, but if you want a brick finish face, you can come and pick the brick that you want and then give it a dimension of how thick it is. And then you have a cut pattern, you have a surface pattern, you have your regular appearance if it's just shaded, and then you have what the rendered appearance will look like when we render it. So that's really important to, you can kind of see here, like this is our cream brick. It's got some lap siding. We've got our shingles on here and all that's painted in a sense from the material browser. And so there's a ton of materials in here. Typically we like don't use half of them, but they're just there. Like if I just want wood to show a wood cut dimension, that's how I'd show it. I would try to avoid going the hatch pattern route and be like the thing that I'm cutting needs to have a wood like hatch pattern. And so I'd go and change that in the visibility graphics settings instead of it being in the just a detail pattern. Scope boxes, we use these for really large. I know I'm running out of time. Um, Scope boxes are great for large buildings. We have the ability to cut the building into two pieces and then for that to be like a match line property across the project. So if your building does not fit on a sheet at an 1/8 inch scale, then we'd have to use a scope box and a match line, and then you can name the scope box and then put that scope box on a work set if we wanted to control it like that. We use them for the condo documents for Everly, which was really helpful. They are three-dimensional, so I can make sure that I can see the scope box on each floor, and then they have a slight overlap to make sure that you're capturing each of the scope boxes. And a scope box is different than a crop region because a crop region is the overall region of the view. So I can say I want to have my overall view, and then I want to have my scope boxed view in terms of like here's my quadrant that I'm working in on the building. But you can have your overall view that's controlled by your crop region, which is the little like it's got the balls on it, and you can like flex and move this thing. You can also split it, which is the little lightning bolt symbols, and that's it. Does anyone have any questions? I know I kind of went long, but just trying to breeze through some overarching vocabulary of what we talk about.
One comment I did have about detail items and your geometry.
Mhm.
Um, I know what I've done in the past is I know you said your detail items won't move with your geometry. One thing I have done in the past is just lock that geometry to your wall.
Mhm.
For example, if you have a wall section, let's say your wall section isn't going to adjust. I mean, in an
Mhm.
ideal world, that's just for folks who might get frustrated if they're saying, okay, I drew this wall section. Now we have to move the whole wall. Now I got to move. Now I have to go back my wall section, move everything. If you take the time to go ahead and lock your stuff to your walls beforehand, then it saves a little bit of a headache because then all your detail items and your lines will move with your wall.
Correct. Yeah, and that's a good point because when we talked about constraints, you can constrain dimensions. You can also just like lock stuff in place and be like, hey, my insulation is locked to the middle of this wall. So if my wall moves, my insulation moves. Like those are things that we can embed into our projects to save the tediousness that comes with wall sections, with the final CD lift that's like, oh my gosh, like I halfway did this before and now everything's like moved because the project changed. Like the biggest thing that I've learned from working in architecture is that the thing that changes the most is change. So if we can just anticipate that it's going to change and build that into our projects, the better we can be at anticipating that call that's like, hey, I've got some changes. Um, so think about that. That's a great topic, Elliot, and that's something that we can talk about further, but just know that that can present issues. Like you can get into this and it's like, I can't do this. I can't do the thing that you said because it's constrained. And then you're like, how do I unconstrain it? Um, so it can make you frustrated, but it's for a a good reason that we do the things that we do, like locking it down. Anybody else?
Is it fair to say that one of the most important things to kind of understand is what you're actually drawing or creating in a view versus what you're putting in a model? Like you were talking about insulation just then, and I'm like, all right, if I if I blow up a view to have a detail, is there any line work that I'm doing there, or is that just all modeled line work and I'm noting it and just
If you
making
keep creating modeled views, you would just keep seeing more model. You'd have to keep that's where it's additive to add the detail in. Like we show like, hey, here's the finished face of the siding, and then you're gonna tack on your trim, and then your window sits behind that, and like, but you're not seeing that there's a header there. Like you're just gonna see that there's a void, and like we know that there's a header there, so you'd have to
Mhm.
go in and add your 2x6 header and like orient it properly. You'd have to like make sure that the plywood is like the right hatch. Maybe we want to darken the line, so we like draw plywood in.
Right.
And then maybe like there are some bracketing details that like we need to show that of right above the header of the window. That's where we'd start to add that information where it's like you'd see the element, like you'd see the bracket, but you're like, I need to see like a bolt go through there and like that there's
Right.
like where the lag is and all that. So that's the level of detail that you go to with the detail view.
Got it.
Sometimes, especially as we're going into like SD and DD, we don't add any of that detail. Like it's purely model that we're showing and we're trying to dumb it down to be like it's a box you're seeing, or like there are no layers to the walls. And we're working, but like the team, the senior leadership team, the way that we present projects, it's still in discussion of how we want to present out of Revit because we can easily present way too much information because we have like the ability you saw with like the project browser, you can just create infinite amount of views.
Mhm.
But then with Riverlights, I think the Riverlights team could all raise their hands and be like, I drew too much. um, because we started realizing we had too many drawings. And that's where Nick really leans into lean architecture and making sure that we just draw what's enough so that we can focus on what's important, which is the design and the coordination of the project versus the tedious details that no one looks at. So um, hopefully this gave some people a step into like, oh, I know what you're saying now. I can relate to what this is. So I'm trying to get better at relating this stuff to CAD so that way y'all don't feel it's like such a big leap to jump into Revit. It's like if CAD was in elementary school, Revit is in college. There's a better understanding of how the building functions, how the project can flow, and how managers especially can be able to understand what's going on without having to get really like granular. So I appreciate y'all's time today, and I'll post this presentation on Teams so that way y'all can go through it at your own pace.
Thank you, Kurt. This was great.
You're
Appreciate it.
welcome.
Thank you.
See y'all. Bye.